अच्छा ये बस पास में क्वेश्चंस करें रिएक्शन kinetics राइट तो वही कंटिन्यू करते हैं कि अच्छा व्हाट नीड्स टू पहले से स्टार्ट करें ठीक है तो अच्छा starting with the first one ये मैंने मेरे ख्याल से मैंने अभी भेजी है वर्कशीट हाँ ये उसमें देखो ग्रुप के अंदर ना आई जस्ट सेंट इट ठीक है अच्छा एनीवेज ये इस क्वेश्चन से स्टार्ट कर रहे हैं ऑर्डर विद रिस्पेक्ट टू NO राइट द फर्स्ट वन with respect to NO so you got two reactants NO and O2 so that means rate depends on NO's concentration we just don't know how does it depend on it that's or power X and it depends on O2's concentration and power is Y right so we just need to figure out so when you're trying to figure out rate with respect to NO then you want to keep O2 constant in this so you're going to compare which two experiments that will be remember O2 has to be kept constant so you're going to compare the first with the third one so I'm going to mention that first then I'm going to compare experiment number 1 and experiment number concept 3 right so what is happening to NO's concentration that doubles right so that doubles and what is happening to the rate of the sorry that doesn't double it actually becomes half हो रहा है ठीक है मतलब 0.05 divided by 1 that's half so 3.5 goes to 0.875 I mean you can use your calculator this would probably be 1 by 4 ठीक है so 3.5 on the 0.875 divided by 3.5 that's going to be I guess 1 by 4 तो ये कौन सा ऑर्डर है which order is this किसको हाफ किया है तो वहां पे 1 by 4 हो गया क्या इसका आंसर rate becomes 1 by 4th so quadratic relationship है that's order 2 ठीक है सर ठीक है that's order 2 so rate is the relationship between rate and NO's concentration is that it's a squared it's order 2 किसको अगर half करोगे ना that's going to become 1 by 4th just similarly which experiments will you compare if you want to figure out the order with respect to O2 इसके respect से कि O2 और rate की relationship figure out करनी है तो you want to keep NO constant so it's going to be which experiments it's going to be experiment number 2 and experiment number 3 क्योंकि उसके अंदर this is constant that becomes half and if you look at the rate that also becomes half so directly proportional so first thing is you're going to compare experiments 2 and experiments 3 concentration of O2 becomes half और आपका जो rate होता है ना that also becomes half so that means it's directly proportional its rate is proportional to O2's concentration and the power is 1 ठीक है directly proportional ये clear है ये part सारों को is this clear और फिर वो कह रहा है कि अच्छा चलो फिर वो कह रहा है is asking you to figure out the rate constant and the rate equation so it's k rate is proportional to O2's concentration power 1 and it was proportional to NO's concentration and that was squared और वो कह रहा है कि use the equation to calculate the rate constant use the rate equation and he didn't say which particular reaction. I'll take any experiment and I'll put in the values. तो पहले का कर लेते हैं. तो rate is 3.5 is equal to K. O2's concentration is, for the first one, it's 0.05 and NO's concentration is 0.1 squared. तो ये K निकालो, क्या आ रहा है K? उसकी मुझे वैल्यू बताओ, उतनी देर यूनिट्स निकाल लेते हैं. K is, take the units that are given in the table. That's rate is मोल per dm cube per second. को ये सॉल्व करें, K की वैल्यू क्या आ रही है? Mole per dm cube, I'm taking it as X is equal to K mole per dm cube into mole per dm cube squared. So that means K is going to be equal to X minus 2. So it's mole per dm cube to the power minus 2. So mole minus 2 dm X. ये किया किसी ने, ये वाला 7,000. जो ठीक है, 7,000. K is 7,000 and that's the unit for K. Now next one, very easy. State the order of the reaction. They give you a rate equation for this reaction. Okay, you got three things: H plus 1, I2, and this thing. So it clearly states that if there's nothing written, that's 1, right? Power 1. H plus 1 is 1. And I2 is missing. So that means I2 must be what? It must be order 0. That's why it's missing from the rate equation. So 0. This is 1 and this is 1. So state the overall order of the reaction. Actually, the overall order, remember, whenever you hear the term the overall order, those combined order, that's 1 of this, 1 of this, and 0 of this. That's 2. That's the overall order of the reaction. But anyways, you already had the rate equation. And you similarly, they're asking you to calculate the rate constant for this reaction. So all you've got to do is you just have to plug in the values. You already have this equation. So that's very easy. So say rate diya hai. So we're going to plug in the values. It's going to be 5.40 times 10 power minus 3. That's the rate. Is equal to K times this propanone concentration. That's 1.5 times 10 power minus 2. And that's power 1. And H plus 1 concentration. That's 7.75 times 10 power minus 1. So this is power 1 and this is also power 1. That's it. You can find the value of K. And you can also find the units of K, which is mole per dm cube per second. So that's X is minus 1, K times concentration times concentration. So एक X काट गया. K would be X minus 1, S minus 1. So it's mole minus 1 dm3 and S minus 1. ये मैं K की वैल्यू निकाली किसने? अच्छा, K आ रहा है, that's 0.465. I guess that kind of looks right. So that's going to be my answer. I hope that's right. ठीक है. अच्छा, complete a table placing one take. अच्छा, इसमें effect of decreasing. अच्छा, one thing that we did not mention over here was rate constant. ठीक है, एक छोटा सा point है. Where did we study rate? I mean, we did 3 methods of finding order of a reaction. So I'll just add it somewhere about the rate constant. So remember, whenever you have a rate equation, it looks like this. That you've got rate So you've got rate and it's equal to K times the reactant concentration. So you have reactant concentration, and then you have a power which is the order. It's 0, 1, or 2, right? So that's the general equation of a that's the general rate equation. इसके अंदर remember this, that when you talk about K is a constant, but there's one thing that changes the value of K, and that's this one specific thing that changes the value of K. और वो जो है ना, that's temperature. K increases with temperature. Remember that. As the value of K, it increases with temperature. Why does it increase? Because if the reactant concentration is the same, the order is constant. Every reaction is going to have a very specific order. That will not change as well. आप find करते हो, but it's always constant. Like if it's order 2 with respect to something, then it's always going to be order 2 with respect to that thing. क्योंकि mechanism तो change नहीं होने वाला. So you can change the reactant concentration, but what if you're not changing the reactant concentration and the rate is still going up? It usually goes up when you increase temperature. तो होता ये कि when you increase temperature, your constant value actually increases. So this K is actually dependent on temperature. It's a constant, but it changes when you increase temperature. यानी आपने reaction में कोई change की नहीं है, and you're increasing temperature, and the rate of the reaction goes up. So that simply means that your value of K is increasing. ये बात clear है? Anna clear है? Risha? Abhi, is this clear? Seem clear है? वरना हमने टेम्परेचर स्टडी नहीं करना, ठीक है? वी जस्ट इन्वेस्टिगेटिंग हाउ डज रेट एंड द रिएक्टेंट कंसंट्रेशन वेरी and how do you figure out the order, ठीक है? So we're not studying K as such, but if you keep everything constant and you increase temperature and the rate goes up, then that only means your K is actually changing. So just remember that. So उसके अंदर ना we complete a table placing one take and describe the effect of decreasing temperature on the rate constant. So when you decrease temperature, the rate constant decreases. And when you decrease temperature, the rate of the reaction also decreases because of that. Okay. So I've been given a graph. From the results, a graph is produced which shows how the concentration of I2 changes during the reaction. Describe how this graph could be used to determine the initial rate of the reaction. So all you have to do is when you have to figure out the initial rate of the reaction. But remember, when you do a comparison, you always measure the initial rates because the rate of the reaction changes with time. The initial rate is you're going to make a line and you're going to try and figure out the gradient of this line. So measure the initial gradient. So measure the initial gradient of this line at t is equal to 0 seconds. That is what your initial rate is. So whenever you compare, you just compare the initial rates because all reactions would eventually go to 0 anyway. So बाद में rate compare करने का ना फायदा कोई नहीं है. It's always you always measure the initial rates. So ऐसे यहाँ पे कह रहे on the axis below, sketch how the initial rate changes with different initial concentrations of. अच्छा, now the equation that they had given us, ये propanone का क्या order था? It was order 1, right? Rate and this thing, it was in order 1 directly proportional, right? So he's saying sketch this graph. That rate is proportional to propanone's concentration. And they already gave us that it's order 1, right? So direct proportionality, what is the graph of direct proportionality? It's going to be a straight line, right? Is it clear? And we did this in a, is this clear? तो अच्छा इस पे आ जाते हैं. As I explained the meaning of the term rate determining step. So it's the slow step in the reaction mechanism on which the rate depends. Reaction mechanism. I explained to you that fast step, no matter how fast it is, it will not determine how the speed of the reaction varies. The reaction on which the rate depends. As you use this mechanism to, as you're saying, step one, the rate of the reaction between, I mean, there's a step, the different methods, there are different steps given. Step one, step two for a particular reaction. It's a three-step mechanism, and the step one is the rate determining step. So that's the slow step. So rate will depend on these two only. Okay? Any reactant that's involved in the slow step, rate depends on that. So that means rate will depend on किन दोनों के ऊपर. It's going to depend on C4 plus ions, their concentration, and it's also going to depend on Mn2 plus ions and their concentration, right? So it's going to be order one with respect to both of them. Okay? So that is the overall equation for this reaction. Sorry, that's the rate equation. They didn't actually ask for the rate equation. They're asking for the overall equation. Overall equation kya hogi? It's going to be the sum of all the everything. The overall equation. So इसका answer ये नहीं है, ठीक है? That's the rate equation. That's not the overall equation. Add up the reactants, add up the products, right? So if I do that, तो Mn3 plus cut हो जाएगा, Mn4 plus will get removed, Ce, who else will get removed? I guess nothing else. So left side pe you'll have 2Ce4 plus, and there is I said the Mn2 plus gets removed as well. So you got Mn2, you don't have Mn2 plus, you've got Tl plus 1. ठीक है. Or product में you'll have 2Ce3 plus you'll have Tl3 plus, right? I guess that's the rate equation. ठीक है, that's the rate equation. तो इधर actually ये लिखना था इस जगह पे ना, you had to write this. ठीक है, this one is actually the rate equation, not the overall equation. Overall equation is the reaction equation. So this was the overall equation, this was the mechanism of this reaction. So what is the role of Mn2 plus? What does it do? You added Mn2 plus, वो end में Mn2 plus फिर बन गए थे. So कौन सा type का catalyst है? It's a homogeneous catalyst. Homogeneous is there because the state is the same. It's an ion that's also, I mean, the reactants are also ions, right? So they must be aqueous ions probably. So homogeneous catalyst, and how did I know it's a catalyst? That Mn2 plus remains unchanged in the reaction. ठीक है, ये clear है? And now see Shan, is this clear? See, last time किया था, ये भी discuss किया था कि what happens when temperature increases, the value of K also goes up. In another experiment, the reaction between chlorate ions and iodide ions in aqueous alkali was investigated. A solution of iodide ions in aqueous alkali, iodide is I minus 1. Alkali, that's always minus 1, right? was added to a large excess of chlorate 1 ions. I don't know what chlorate 1 ion is. Cl. See here. This is ClO minus 1. That's chlorate 1 ions. So ClO. Achha, it was measured. Describe how the results of this experiment can be used to confirm that the reaction is first order with respect to I minus 1. So, so I minus 1 was measured at regular intervals, right? Now, I minus 1, I think, is my reactant, right? I think it's my reactant. That is chloride ions reacting with iodide ions, right? So my reactant is going to get used up. So अगर यहाँ पे देखो ना कि if you plot the reactant concentration with respect to time, right? So there are three ways in which the reactant concentration will decrease. One way is that it will just continue to decrease at a constant speed. That's zero order. That means कि उसके कम होने से ना speed पे कोई फर्क नहीं पड़ा. It's going exactly with the same speed. It's just decreasing constantly. The second one is order 1, that if the reactant concentration decreases, the reaction slows down proportionally. In that case, half-life is constant. And then you have order 2, which is that every time the concentration of the reactant decreases, the reaction takes a much longer time it takes a much longer time for the reaction to finish. That's order 2. So half-life method, okay? So whenever you plot reactant concentration with respect to time at regular intervals, so how could it confirm that it's first order with respect to I minus 1? So measure the half-life of I minus 1 concentration. And it should be constant. It's going to give you a curve. Its order 1 is that the half-life would be constant. An order 1 graph would look like this. So ये वो half-life का आ गया. और the next part is there's a 3-step mechanism, so reduce the overall equation. So just start cutting things that are common on both sides. Water भी गया. और क्या गया? That's what we get. HClO, that's gone. Anything else? I guess. Let's see here. EHIO cutting it. As the final reaction is it's ClO minus 1 plus I minus 1, and the product is Cl minus 1 plus IO minus 1. That's it. Identify a step that involves a redox reaction. So I guess it's this step 2, right? That's definitely a redox. Minus 1 है यहाँ पे I plus 1 है. So step 2. Explain your answer. So I is minus 1, or HIO में ना I is, अच्छा, HIO में I is actually plus 1. So that is oxidation. That is 2 electrons lost. So you can just say that I goes from minus 1 to plus 1. That's it. Part 1 ये वाला. The part 1 is that he says there's a reaction that's happening between chloride and iodide ions, right? And he's plotting I minus 1 was measured at regular intervals. Now remember, I minus 1 is a reactant, ठीक है? तो हमने जब हमने किया था ना कि how many ways can you figure out the order of reaction? The second method was half-life. Okay, if you plot the reactant concentration with respect to time, all reactants they eventually go to 0, right? When the reaction happens, so slowly the reactant get used up. So concentration अगर reactant की कम होगी ना, if it decreases, then the reaction should slow down, right? But इस वाले case में order 0 में, if the concentration decreases, there should be no effect on the rate of the reaction. That's order 0. So the reaction just happens at a constant speed. Either ये कि order one में the half-life becomes constant. Every time the concentration decreases, the reaction slows down. It takes longer and longer for it to finish. Or order two, you've seen graphs, so you have to remember that. That how does the reactant concentration vary with respect to time? Is that clear? अब ये clear है half-life वाला? तो उसमें अच्छा उसमें खाली ये करना है कि you just have to tell them that if you're plotting the reactant concentration at regular intervals, just measure the half-life. And it should come out to be constant if it's order one. If it's first order, they already told you that it's first order, so it should come out to be for a first order reaction. It should come out to be constant. तो ना उस तरह की shape होगी उसकी. अच्छा दूसरा इसमें ये भी है कि अच्छा now एक चीज खैर वो चीज हम बाद में करेंगे. I'll explain that later. Like ये वाला part कर लेते हैं. Actually, there's still certain things left. I'll just write it down, just minor things. Okay, that is एक जो part है ना, that's P5. ठीक है, you might get questions. तो वो मैं इधर add कर देता हूँ. So you'll have to do the two things. One is P5 reaction kinetics. So maybe we'll do that tomorrow. Kuch nahi usme, we're actually done with the topic as such, but plus I think we need to go over homogeneous and heterogeneous catalyst as well. So मैं वैसे note down कर रहा हूँ so we can. That's catalyst. So वापस उस पे आ जाते हैं कि you've got you see in each ClNO2 molecule the nitrogen atom is bonded to the chlorine atom and bonded to each of the oxygen atoms separately. So the nitrogen atom is bonded to the chlorine atom, right? So chlorine has 7 electrons. So nitrogen must be making a covalent bond, right? Or it's and he's saying that it's bonded to each of the oxygen atoms separately. Remember, oxygen that makes a double bond, right? So oxygen ka jo hoga na, that's shaded dot. So that's oxygen, and that's so nitrogen is group 5, so it has 5 electrons. It usually makes 3 bonds. There's a lone pair as well. So one of the bonds will then be a dative bond. Actually, these should be crosses. 1 second. So this one over here will be probably a dative bond because nitrogen cannot accept more electrons. So the outer shell complete ho gaya tha. It's making 3 bonds and then there's a lone pair. The oxygen needs 2 electrons, so that's a dative bond. It's where a lone pair of nitrogen, if you remember this, like in NH3, what happens in NH3? Okay, you've got nitrogen and it's got a lone pair, and if there's an H plus one that needs electrons, they're going to end up forming a dative bond. So यहाँ पे exactly same thing is happening. That nitrogen is making a double bond, it's making a single bond, so that's it. Nitrogen makes 3 bonds, that's about it. Or you got a lone pair of electrons, and so what happens is that a dative bond is formed. Is this clear? You will have dotted cross diagram. Is this clear? I said, write the rate equation. They already told you the reaction between Cl and NO2 and NO2 is first order with respect to each reactant. So, I mean, everything is given. So, it's K Cl NO2 concentration, right? And NO concentration, that's order 1, right? Deduce the units of the rate constant K when the react concentration of both gases are measured in. So, you just have to deduce the units of K. So, rate is mole per dm cube per second. K into times mole per dm cube times mole per dm cube. So one of the x gets cancelled out and K will come out to be equal to x minus 1, s minus 1, which is basically x is mole per dm cube. So that's mole minus 1 dm3 and s minus 1. State explain whether or not the reaction would take place in a single step. So you've got a question here, single step. Yes, it probably can. Okay, let's say if it's ordered 1 with respect to both of them, right? So he's asking, can the reaction happen in one step? If it happens in one step, then that is the only step, right? बस एक ही step है ना, that's it. So this is the reaction, right? So if this is the only step, then the reaction depends on only that step. There's only one step, right? उसको slow step तो नहीं कहेंगे because slow is in comparison, right? But since there's only one step, then that is the only step that determines the rate of the reaction. So that is your rate determining step. So the rate of the reaction will depend only on that step, right? So it will depend on NO's concentration, it will depend on Cl NO2 concentration. Hence, it will be order 1 with respect to both of them, right? This is step number. So you'll still get order 1 if you just had a single step. The idea clear है कि अगर यही step होता, there was a single step, you'll still get order 1 for both of them. The rate will depend on that step because that's the only step. So that means rate will depend on this and it will depend on this, and you'll get exactly the same rate equation. So is that clear that the reaction can happen in a single step or possibly can happen in a single step? Is this clear? ये वाला पार्ट समझ आया सीप है ना ऋषा I'm just saying that for example we did mechanism ये था ना एक if I told you that step 2 is the slow step, just saying, so what will rate depend on? Rate of the reaction depends on the slow step only. So that would mean it will depend on C4 plus and Mn C plus, right? So if step 2 is the slow step, right? So that means rate of the reaction will depend on C4 plus and it will depend on Mn C plus, right? इन दोनों पे डिपेंड करेगा. And MnC plus is an intermediate that was made in the previous step. So that means MnC plus instead depends on Mn2 plus and C4 plus. So उधर में क्या डाल देता है? I would replace the MnC plus with C4 plus and Mn2 plus, right? So उससे क्या होता? My rate equation would have been there would be C4 plus coming in twice, right? It's going to be squared. और Mn2 plus जो होता ना वो once होता. I'm just repeating this, that this is what we learned, that the rate of the reaction depends on the slow step. So in दोनों पे depend करता है, and then I would figure out that Mn3 plus is an intermediate and it depends on Mn2 plus and C4 plus. So when I say that rate depends on Mn3 plus, it in fact actually depends on Mn2 plus and C4 plus, right? तो ये मेरे पास आ जाती है equation. यहाँ तक clear है ना? ये मैं वैसे just revising stuff. तो अलीशा ये clear है ये वाली बात? अब now this is a multi-step mechanism, right? So remember the mechanism decides. इसको हटा लेंगे, इसका question से कोई ताल्लुक नहीं है. One second. I said now remember that I said, remember the mechanism decides what the order of the reaction is. I said, mechanism decides. So if you go back to your question, if the question states that this is the only step in the whole reaction, there's only one step. So yahi aapka, that's your rate determining step, right? Because that is the only step. You don't have a choice. So that means rate of the reaction, if you speed up this, there's a single step, right? If you speed up this, the rate of the reaction will speed up, right? So that means rate depends on ClNO2 and it depends on NO because that's the only step, right? Multi-step hota phir koi aur issue hota कि the rate would depend on the slow step. But in this case, rate only depends on ClNO2 concentration and depends on NO concentration, right? And it's going to be order one with respect to both of them. And I got exactly what he's saying. तो उसने बस कहा था कि can it be possible that it is just a single step reaction? So it is clearly possible that it can be a single step reaction because even if it's a single step reaction, which we don't know whether it's a single step reaction, but if it's a single step reaction, so मेरे पास जो orders are ना, that's exactly what he stated over here. I'm getting exactly the same answer. Anisha, be clear? So that is a possibility. It can possibly take place in a single step. मतलब उसका जो आंसर होगा ना वो इधर ऊपर लिखा हुआ. You just have to explain that if it's a single step, then you'll still get the same order. इसको मैं इधर लिख देता हूँ just a second. So yes, that's possible, right? चलो ठीक है और क्वेश्चंस करते हैं कल करते हैं. I just have to one is P5 related reaction kinetics. We'll probably do that a bit and we'll just do some more questions ठीक है of this. Say okay, I've shared the worksheet as well. Say okay everyone. Take care, office.